Arvind sir, please begin.
Okay. Narendra sir, are you ready?
Yes, Dr. Yadav.
Good afternoon, everyone. So today we have with us Dr. Narendra B. Londe, who is working as an associate professor and head of electrical engineering department, NIT, Raipur. Dr. Londe is having expertise in medical signal and image processing, machine learning, pattern recognition, medical and ultrasound images, biometrics, brain-computer interface, speech signal processing, deep learning, and biomedical instrumentation. He is the main of biomedical. Right now, he is having more than 100 journal papers under his belt. He has published more than 10 book chapters and around 48 conference papers. Since he's a researcher, he's having more than 6 projects under his belt. Just to name a few, machine-based behavioral multi-parametric pain assessment system, which he has completed, and this project was sponsored by ACRB. Another project from DST CSRI, development of efficient Devanagari script input-based P300 speller system for brain-computer interface. Similarly, from CPRI, improving cybersecurity in smart grids operational technology infrastructure using deep learning-based approach. Now, without wasting much of the time, now I would like to invite Dr. Narendra Londe to deliver a talk on ECC-NET, an ensemble of compact convolution neural networks for pain severity assessment from face images. Narendra sir, over to you.
Thank you, Dr. Yadav. Good afternoon, everyone. I actually thank Dr. Yadav and the entire Parallel University administration for giving me an opportunity to share this our latest research work, which is an very good example of application of deep learning. So when I received a call from the Dr. Yadav, I thought, why not to teach the students or the faculty members of Parallel University to apply this deep learning approaches on one particular application. So I chosen my one project that I already just described by Dr. Yadav, that is a pain assessment system. So here in this my presentation today, basically I have taken the part of that project where actually we have tried to assess the pain of patients, those who are going to the medical hospitals from the face images. Okay, so that is what is the today's title, that we have used this an ensemble of compact convolutional neural networks for pain severity assessment from face images. Okay, now let's go to the my next slide. Now the very basic question comes in our mind when we talk about such topics, that does it really require to assess the pain? What does it mean? Whether it is an indication of any medical condition? Okay, so a lot of questions comes in mind. What will be the benefit of doing all this assessment? That is the basic question comes in our mind. So I just want to tell you a few I just want to answer those questions first. That yes, what is pain first? That it is an unpleasant sensory and emotional experience, basically, that we experience when we are suffering through some actual or the potential tissue damage, or we call it as a some sort of damage, physical damage, right? That when our body is having some sort of damage, physical damage, in that cases we experience this uh, unpleasant sensory and emotional experience. That is what is the pain is all about. Okay, now why pain assessment? Now if you just go to the literature and those who are doing the medical or uh, medical studies of the pain, okay, what they have suggested or what they have found, if you will just see the paper of this cord a little, it says that pain is a chief complaint for 52.2% of the patients, those who are visiting the emergency departments, whereas only 34.1% people are there, those who are not complaining about the pain. Even further to that, Gregory et al. Has said that acute pain, actually, that is a significant symptom in most of the hospitalized patients. Okay, and that is up to that percentage is up to 35% for the severe pain, and approximately 50% patients are reporting the normal pain or moderate pain or mild pain. Okay, but 35% of the patients are reporting the severe pain. Means when they come to the hospitals, their first complaint is the pain, that I am having a pain on the back, I am having the pain in my hand, or my leg is, say that if there is some accident is there, then there is no need to mention the pain. Anybody can understand from their voice of the patient that they are in severe pains. Okay, likewise, Zuega et al. Also has mentioned that pain is a prevalence in hospitals up to 83%. Okay, so it means that if some patient or some particular medical conditions is reaching to the hospital, the very first or very common complaint is the pain. Okay, and when the doctors treat that patient, or when the doctor try to diagnose that patient, they consider that pain as the first indicator. Okay, they use that indicator to understand the uh, possible difficulty with the patient. Okay, and to further give the treatment to that patient. Okay, so this has the increasing need of the pain management. Okay, for that purpose it is required that we should have the increasing pain management. Okay, so basically, when the doctor are treating those patients, they are first will be they the first task that they will be doing is to manage that pain, right? Now, looking into that management of the pain, you may be also aware that there are people, those who are suffering from the persistent pain. Okay, that is survived from some formerly lethal diseases such as cancer, HIV, or cardiovascular disease. So it's not like that the pain is a momentary thing. There is a persistent pain also. There is a these persistent pains are having major implications for the individual suffering from the pain and for the family and the friends. Okay, so their complete family and the friends, the people those who are surrounding them, they remains into a uh, uh, they remains into a problems because of somebody is having the persistent pain. Such a treatment such as surgery or chemotherapy or radiotherapy also often cause the pain. Even a lot of people are suffering from the chronic pain also. If you are aware of that, that somebody is having say arthritis, so they will be having that pain for long time and they will be habitual of it, and that sort of pains will be surviving with the patient for a long time, right? So in that cases, due to this kind of pain available that retain with the patients, those who are having persistent pain, chronic pain. Okay, those people, they are at their workplaces suffers from loss of productive employees or employment. Okay, means this kind of people, those who are working somewhere, they lose their employments, and the economic cost of caring of such chronic care pain patients is very high, is very high, is very high. Just let me just give an example of the US, that this chronic pain costs society more than cancer, heart disease, and HIV combined. Okay, for that, if you see the example of the US financial impact on the US economy, find out by the people those who are suffering from the chronic pain, that was around $100 billion each year. Okay, these figures are very hidden. Sometimes we are not able to understand that, yes, whether this much expenditure is there or not. But if you'll ask, even in India also, the people those who are suffering from pain, chronic pain, they would be taking a lot of medications, they would be missing their regular work, or they may be taking offs from their work. And if you just accumulate, or if you just accumulate this cost of their economic cost involved into their this loss of employment, or their expenditure towards the medicine of pain, so that amount is very high. Okay, so this is what exactly is the reason that this pain assessment is very important. Okay, so if you are able to assess this pain, okay, and then that will be help the doctors to manage the pain and diagnosis and the treatment of the diseases. Okay, the valid and the reliable pain assessment is very important. Okay, now if you are as we have understood this, that the pain assessment is important, understood. Okay, no, but that assessment should not be a superficial, because see, sometimes it gets really important that you should know exact that how the pain is. Okay, now say that I am in a pain, I am the first I am actually suffering from an injury first time in my life. So the projection or the projection of the pain from me will be high. Okay, but if somebody is there who is actually uh, have gone through some injuries earlier also, so he's experienced. Okay, he has the experience of suffering from the pain. Okay, so in that case he may not be projecting that pain as a very high, or maybe that particular patient will be projecting it as a mild one. Okay, so this is the there is a variation of the projection of the pain by the different people. Okay, say that some people are those who are very regular with the chronic pain. Okay, even if they found an injury to their some different part of their bodies. Okay, they may not be reacting much to the pain. Okay, or they may not be expressing the pain much. Okay, so that is where the reliability and the valid assessment of the pain is needed. Okay, because whatever the present methods are there, subjective methods are there for the assessment of the pain, they are basically, these are two. Okay, one is the visual analog scale, VAS, you can see on my screen. Then another method is the numerical rating scale. In the visual analog scale, you can see these are the symbols. Okay, facial symbols are there, while in case of numerical rating scale, there are the numbers given for the pain range. Okay, say that if your if if the patient is reporting the pain for the rating of say 1 to 3, so it is a mild pain. If the patient is reporting from 4 to 6, then it is a moderate. If the patient is reporting it from 7 to 10, it is a severe pain. Likewise, in the visual analog scale, you can see here that if the facial if the patient is reporting a face of smiling like this one, so there is no hurt. Okay, likewise, if it is hurt a little bit, then the second phase will come, third phase will come when that patient hurts little more, or if it hurts it even more, then the fourth phase will come, or fifth phase will come when it is hurts whole a lot, right? And the last phase will come when it hurts worst one. Okay, so if you'll see the scale, so the scale is ranging from 0 to 10 here basically. But by looking at those facial expressions, then we have to the patient will be indicating this facial expression, and based on that facial expression, we are going to find the numerical value of the pain severity. Okay, whether it is no pain, mild pain, moderate pain, severe, or very severe pain. Okay, so this is how the patients are reporting the pain to the doctors or to the medical staff. Okay, so at present, patients are being the patients are the people those who are reporting the pain. But as I told you just now, that patients reporting of the patient is not reliable. Every patient can have a different projection of the pain. Okay. Okay, so in that so due to that, these subjective methods are very, I must say that they are very highly subjective basically, and it requires really a proper communication between the healthcare experts and the patients. Okay, But there are many cases, or there are many human beings where, like infants and the impaired patients, though, or dementia patients, those who cannot self-report their pain also. Okay, in that cases, this visual analog scale or the numerical analog scales, this will not work. Okay, so what is the solution to this? Okay, what is the solution to this? That we can develop some objective method or computer based some pain assessment method, okay, where the pain will be detected automatically, and the severity of the pain can be reported to the healthcare professionals by giving some numbers, okay, or saying that it is a mild or moderate or severe or very severe. That will be measured based on some parameters, based on the parameters like physiological or maybe behavioral parameters, but it will not be taken from the patient. As I told you that patient's reporting of the pain is very highly subjective, and it cannot be a reliable way of assessment of the pain. Okay, so that is why what we have proposed, we had proposed that there should be an objective method which should be based on some another parameters, and rather than self reporting of the patient. Okay, which will be more reliable, and based on those parameters the pain can be measured by the computer system. Okay, so that is what we have done in our this project. So what we have done here, that automatic pain recognition system based on say behaviors. When I said behaviors, it is like facial expressions or vocalization. Like if I'm in a pain, so I'll be crying, okay, I'll be having moaning sounds, okay, or I'll be having some body movements, very uh, systematic body movements will be there when I'll be having the pain. Okay, so those body movements can be observed, my voice may be observed, or maybe my facial expression may be observed, in order to find out whether how much is the pain. Okay, so for that automatic pain assessment I can use these three behavioral parameters. Likewise, I can also use the physiological responses, uh, uh, which such as like maybe you people can put up some EEG machine or ECG machine, and from those physiological responses I may be able to find out the pain. Okay, now in both these cases, recognition of this recognition systems may also help to gain new knowledge about the pain. In both of these cases, this will not only help us to understand the pain or to understand the severity of the pain, but it also gives us an opportunity that to understand the dynamics of the pain. Because when you will be measuring the pain by using some such computer based system, so you'll be monitoring it for the 24 by 7, right? This sort of facility cannot be given in the subjective method, because uh, when your patient is reporting the pain, so he will report it once. Okay, you are not going to ask the patient to report his pain again and again, right? And based on one that single reporting, you will be the doctors or the medical staff will start the medication of that patient. Okay, instead of that, why not to have that patient's monitoring, pain monitoring of that patient for a continuous time, just like that the way we are observing the cardiac situation by measuring this continuous EEG, ECG, or brain behavior by continuously monitoring the EEG. Okay, so if you are able to recall from the hospital's environment, that there are different monitors there, and they are continuously showing you the ECGs or the EEGs. So what is that? It is a continuous monitoring. That way, this pain can also be monitored if continuously, if we are making it a computer based system, if we are making it an objective based system, right? So that is what is the objective here. If we are doing that, if we are continuously monitoring the pain, what will happen? It will also give us an opportunity to understand or to learn more about the dynamics of the pain, right? So this sort of systems are not there in the hospitals at present, but this sort of systems can come soon into the hospitals. Okay, now just let me go into this briefs about the pain indicators. That, as I told you, that the pain indicators can be behavioral, it can be physiological, and it can be a contextual also, that you are taking some clinical data or scenes or the pain times. Okay, while in case of physiological, like vital signs or the brain dynamics, as I told you, vital signs in the sense say that cardiac condition or muscle condition or maybe brain dynamics, all that sort of things can be come under the physiological. Behavioral, as I told you, that facial expression, crying sound, or I will say pain sounds. Okay, or vocalizations or the body movements. So these are the types. Now, in the machine-based system or this objective or computer-based pain assessment systems, basically whatever the literature is there or whatever the recent work that has been proposed, it is based on these two parameters, behavioral based also and physiological based also. Okay, but if you'll see, majority of the literature is based on the physiological parameters, where the heart rate, the then RR interval or the SpO2 or the brain dynamics are observed. Now, it's a very common thing. I want to tell you one thing, or you people can also understand it very easily, that when somebody will be in a pain, when that patient will be in a severe pain, it is very obvious that that person will be having the body movements, right? And if that person is having the body movements, you already know that ECGs or EEGs being acquired for a patient, those who are having a body movements or muscle movements, though in that cases the readings of the ECGs and EEGs will be not reliable. Okay, for having the correct ECG and EEG, it is a necessary condition that the patient should be in a normal condition, normal physical condition. He should not have any movement into the body, not even the, if you are able to recall the literature, it says that even you should not have the eyelid movements also. Okay, that creates an interference or that creates an errors into the EEG and ECG signals. Okay, so in that cases these physiological based approaches are totally not usable. Okay, though in the literature till date only these approaches are actually are applied, but these are not usable at all. Okay, if you understand the technique behind their measurement, you will really able to understand that they are not usable. While in case of behavioral, there are pain expressions, as I told you, that pain expressions, crying sound, body movements. Okay, now at present there this pain expression, say that facial expression, face expressions, they are actually being find out by the from the images also, velocity also, model also, and facts base also. And your crying sound or the pain sounds, they are actually being measured by in the frequency domain, substral domain, time domain. Likewise, there is a body movement is there is instrument based and the velocity based. Now I am here to tell you that whatever these methods are of the behavioral measurement of the behavioral pain measurement is there, these all are instrument based. Okay, and most widely, other than this image, at till this point or up to the very recent times, people were using only this velocity based, model based, frequency based, spectrum based, instrument based, and the means the instruments were used, and from that, based on the output of that instruments, the body movement and the pain sound and the expression, facial expressions are being measured. Okay, let me give an example here. You can just look at this image here. You can see there are accelerometer installed here in this, on the bed of this patient. Okay, there is an activity and the pain level monitors are there, where you can see this is a camera which is actually installed. There is a video monitoring system is here, and you can see here there is a light intensity level recorder is there, sound pressure level recorder is there. So based on these instruments here, the sound is being recorded, based on these accelerometers, the body movement is being recorded. So it is basically a physical signals. Okay, behavioral means instrument signals are being acquired for the measurement of the behavioral parameters. Okay, so for the facial expression, they are taking the faces, like from the videos, from the video monitoring system. Okay, from the accelerometer, they are taking the body movements. From the sound pressure level recorders, they are taking the sounds. Okay, so that was the instrument based approach earlier, and with the help of that, some people have tried to monitor the pain. Okay, there is a multimodal system also there, where actually the combination of both behavioral and physiological parameters are also attempted in the recent past. Okay, but so we also have started our this project, and I just want to inform the audience today that we have concluded our this project. giving them giving an output where we have done the measurement of both this all these three behavioral parameters of the pain, sound, then facial expression and the body movement by using only the videography, only the videos. Okay, we have not used any instrument or any sensors. Our system is totally video based, no sensors are involved, and based on that our video also we have find out the body movements, we have found out the facial expression, we also have found out the pain sounds, and based on that we have given the complete system, pain assessment system, already submitted to the SARB. Okay, and it is a it is it has the measurement for of the all the three parameters once at a time, and that too only based on the video. So if I'm going to use a video, what will happen, that patient will not be disturbed for the pain measurement. Say that I'm putting ECG machine, okay, and patient is having a pain, and during that pain he's having the body movements, he will not allow that ECG leads to remain on his body, right? So that is that, in that cases the physiological methods are totally are not totally are useless. Okay, now let's come to the very first method of pain assessment, that is from the facial expressions. Okay, now in the facial expression based pain assessment, what happens basically, it is a computer vision problem, but it actually suffers from few things like poor lightning, then variability of the facial expressions, that you can have the facial change in the facial expressions, and you can have a partially occluded faces. When I said occluded faces, it means that, see, if in order to have the facial expression, the face must be in front of the camera, but when you will be suffering from the pain, you will not be looking at one fixed camera, right? You will be moving your head down here or somewhere, so it will not be possible to see directly on the camera, and that is what we are calling as a occluded faces. Now the current pain assessment systems, those who are trained for the face images, is actually we have are collected in the lab environment. Okay, and they are collected from the uh, 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 they are collected from the normal volunteers. Okay, they actually given an external excitation, the pain is created in their body. Okay, so let me give an example. There is a heat pad is there. Okay, what we do in the lab environment, how we create that pain, we actually have a heat pad, and we ask the normal our volunteer to put the fingers or to put his hand on the heat pad, and what happens when the heat when that heat actually touches or starts to give pain to that particular or volunteer, then his face is actually get have the expression of the pain, and we ask that particular volunteer to look into the camera, and we actually monitor or we visualize his face, and based on the facial expression, then we find that how much do the assessment of the pain. But that is a lab environment. In the cases in the hospital environment, it is not possible to ask any patient to look into the camera. Okay, or the patient who the real patient, those who will be suffering from the pain, they will not be focusing their attention to any camera, they will be focused on their pain. Okay, so in that real situation, the variation of the head pose will be there, there will be illumination conditions problems will be there, and there will not be any frontal faces. Okay, so how do we measure the pain from the facial expressions? We actually have say that this is the face that is having an expression of the pain, and by when you will have this facial expression or this face image here, so you will be monitoring this action units here. See this action unit number 4, it says that brow lowering. Okay, action unit number 43, that is closing of eyes. Action unit number 6, it is cheek raising. Okay, action unit number 12. Likewise, these action units are defined already there in the literature. You just have to find out these action values of the action units from this facial image, and then you have to calculate this PSPI score, that is pain severity index. Okay, actually it is actually proposed by Prakachin and the Solomon. So it is named with that particular parameter or score is named with those scientists. Okay, and that is why it is called as PSPI score. So it is having an action unit 4 plus action unit 6 or action unit 7 plus action unit 9 plus or action unit 10 plus a action unit 43. So if I just do this addition of the action units of these 4 action units here, I can calculate this PSPI score. And how to measure these action units? But we have to measure these action units by comparing the facial image of this particular patient in the normal condition, no pain condition, and in the pain condition. Okay, and based on that value of the action unit, then you can calculate this pain score. Okay, now in our this experiment, we have used this UNBC McMaster shoulder pain data set, where the shoulder pain is the cause of the pain. Okay, and in this there are 25 adults are there, and 200 range of motion test has been conducted there, and the data modality is the video of the face that has been recorded. Okay, and what is the annotation when we say that I'm saying that this is a pain? Whenever you are applying any machine learning algorithm, it means that you should also have the ground truth, right? Say that I know that I must know that if I'm saying that facial image, whether that facial image is having the pain indication of what category. Okay, whether it is a mild pain, moderate pain, severe pain, very severe pain. Okay, so that is what exactly is there. That annotation is already available, and that is being taken from the self-reporting of the self-reporting from the patients. That patient are reporting themselves. Okay, it is also taken from the observer assessment assessed pain intensity scores. Okay, and it is also take it for the affected and unaffected limbs, that somebody is having the limbs affected. So in that cases also, this with the help of the self reports, the pain indications has been recorded. Now this is our proposed model. What we have done, we have actually proposed an ensemble of the compact convolutional neural networks. Okay, so compact convolutional neural networks. So what convolutional neural networks we have used, or what types of convolutional networks we have used? We have used VGGNet, we have used MobileNet, we have used GoogleNet. Okay, we have taken these 3 nets here, and we have done the ensemble of this 3 nets score, output score of these 3 networks is actually assembled here, and based on that we are calculated the severity of the pain. Okay, so that is what exactly has happened. This is an input image from the video, then there is a face detection is there, and after the face detection we are giving it to the 3 different networks. Okay, now the one question comes in your mind, must be coming in your mind, that why there are 3 networks is required. Okay, why you are not used a single network? Okay, now ensemble, whenever we talk about the ensemble learning is basically is required when you people are not sure about that which network is going to be useful for this your application. Okay, and otherwise if you are aware about the properties of the networks, that say that mobile network or Google Net or the VGGNet, every network is not able to identify or learn about all the parameters present in the images, right? So there are some networks which are very having the specific or I will say learn deep features, or the low level features, or the mild features. Okay, or there are networks which actually learns from the high level features or the mid level features. Okay, so due to that, ensemble learning is actually used in many applications. So here also we have used the ensemble learning involving VGGNet, MobileNet, and the GoogleNet. Okay, now this deep learning, actually networks are nonlinear methods are there, and what happens when we are talking about using the deep learning, we actually required very large amount of the training data is available there. Okay, it is expected, because in deep learning methodologies it is very important to understand, or all of you must be learning it from the literature also, that you require large data to train your deep learning networks, because deep learning networks learns the data, input data in a hierarchical way. Okay, how hierarchical way? It actually learns the raw features first, then it further take the better features from that raw features and learn again from that. Okay, then again it extracts the better features, or I will say fine features, from that middle level features, and learn more about the input data. So that is the thing, it actually learns in stages in a hierarchical fashion. And due to that, in order to have this sort of learning, it is not, it is not possible to learn such things from a very limited data. You should have a large amount of data input to the such deep networks. Likewise, it also learned through the stochastic training algorithms. Okay, when I say stochastic algorithm, means they are sensitive towards the training data. Okay, and they may be different set of weights can be there every time when the training is actually happening. Okay, which in turn produce different predictions. Okay, so many of you must have experimented with the neural networks, and you must have understood, learned that when you are having, you may be having the output of your neural network something at this moment, and maybe at other moment the output is something else. Okay, so why it happens? Because that learning is not the learning is actually changes with the different parameters, different set of weights every time uh, in your network. Okay, so this is why the neural networks having a high variance, and it can be very frustrating to see the final develop final model to use this doing any predictions, right? So that is why a successful approach to reduce this variance of the neural network model is the ensemble learning. So as I was telling you that why you should use an ensemble learning, this is the reason basically that your conventional neural networks are having the very high variance, and if you want to reduce that variance, okay, you should better use the ensemble learning. Ensemble learning helps you to reduce that variance. Okay, it is not only reduces the variance, but also it gives a better reduction, better results into the predictions also. So it's not only reducing the variance, okay, but it also improvises your results. Okay, so why, what happens? Because in ensemble learning, what happens, one at one time one network will be better, and maybe the other two networks are going to performing poor, but you will find that it at any moment of time, or at any instant of your experimentation, one network will be giving you the better results than the others. Okay, so in that cases, your overall performance will be higher one always. Okay, so that is what is the advantage of the ensemble learning. Okay, so what are the methods of the ensembling? That there is a simple uh, unweighted votes, means that whatever the output that is coming, you will just add them up and give given as an output. Okay, cumulative output. Then you can be have the weighted votes, that you can give a weightage to the three networks, different weightages to the three networks. Okay, and then there is a trainer combining function, that whatever the output that is coming from your three these networks, it is going to a cost function. So you can have a common cost function for all the three networks. That can also be done. Okay, so all these are the methods of the ensemble learning. What we have done, that I am now presenting to you. See, first in our experiment, what we have done, we have taken these images. Okay, and in these images, what we have done, we have first detected the landmark points for the for extracting the faces. So we have actually find out by using a computer program these landmark points of the faces. Once we found this landmark point of the faces that you can see in these orange dots, we have extracted this face from this complete image. This is how this is the extracted face. Okay, then we have also applied this face alignment. Face alignment in the sense, if your face is tilted, so that or it is having some angle deflection is there, that deflection we have removed, and we have done the cropping of the images. Okay, so this will be a final facial image that is going to be as an input to my network. Okay, so this is the first network in my ensemble block, which is nothing but the VGG net. Now this VGG net is actually having this structure here. Why this is VGG net? This is actually visual group. There is a visual geometry group network is there at the University of Oxford. They have actually proposed this network, okay, which is having the different combination of the convolutional and the max pooling layers, which are the required or essential layers into the convolutional neural network. So we all know that in the convolutional neural network there is a convolutional layer, there is a max pooling layer, but they have used a very specialized configuration of that convolutional layers and the pooling layers, like this one shown into this diagram, where actually there is a two convolutional layers are coming first, and then there is a pooling layer, then there is another two convolutional layers are coming, then there is another pooling layer, then there are three convolutional layers are coming, and then there is a pooling layer. So likewise they have done this, five convolutional layers are there, five types of convolutional layers are there, followed by the pooling layer, and then there after that at the end they have used three dense layers. Okay, so if you'll just look at this diagram also, you will be able to know that yes, if this is your input image, then how that image will be flowing through this your VGG16 network. Okay, see, to all the attendees here today, I just want to tell you that it is, you have to experiment with the convolutional neural network by changing the convolutional layer filter size, maybe with the number of convolution in the changes in the number of convolution layers. Okay, where to put how many dense layers you have to use. Okay, you have to understand that by understanding your application area first. Okay, as you know that if you feel that there are images where which can provide you the which can provide the features, if it is being convoluted again and again, it will provide more and more information, then you can pile up more than one convolutional layers into your network, right? Like in this dense layer, in this dense network, when you are when you are aware that whatever the output coming from this network, it is not going to be if it is not going to be in a discriminative as these all convolutional layers has trained or learned a lot from this input data, what will happen, the discrimination levels into the output values of this pooling layer will be uh, will be small. In order to increase that discrimination level, you should have more than one dense layer. So that is the reason where you will be able to understand that how many dense layer I should use. Okay, if the discrimination levels are very poor, you should use more and more dense layers, right? That is what exactly has been done here in the VGG16 network. Okay, that is a conventional VGG16 network is there. We have modified it for our own network. So what modification we have done, we have changed the filter sizes or some optimizers and everything, small things inside the network, and that is why we are calling it as a MVGG net. Okay, modified VGG net. And what exact modification we have done, that is tabulated here into this table. Okay, you can see here this is our L0, L1, L2. So we have taken total 11 layers here. Okay, 11 layers here, and if we'll just look at this, we have all instead of taking the total 16 layers, we have reduced that into the 11 layers. Okay, we have taken two dense layers, and even whatever we have taken convolutional layers one only. Here also convolutional layer one, but if you'll see here into this max VGG16, there are more layers. So that is why we also, as I have used here less convolutional layers, I am calling it as a compact structure. Okay, that is what I have said into my title, that it is a ensemble of the compact convolutional neural network. So when I'm using less number of convolutional layers, I'm making my VGG16 compact, right? Okay, let's move ahead. Okay, now there is another compact network is there, that is a second compact network. What is that second compact network? Yes, I have used here in my second network, I have used a compact net which is having this configuration, where it is having influence layer, then there is a convolutional layer, batch normalization, ReLU. Okay, so this is a standard configuration. Okay, you will be having the convolution, then you will be having a batch normalization, then you will be having the activation function. Okay, so likewise this is the second layer and third layer and fourth layer. So this is, we have developed this one where actually we are using this different sort of layer configuration for our this compact network. Okay. Third one, what we have used is the Google Net. Okay. Now in Google Net, what happens basically, let me show you that this is the detailed structure of the Google Net. As it is not visible, as it is a very large diagram, I cannot accommodate in a single slide, but I tried here. You can just look at here. This input is coming from here and then it is starting here, right? And if you just look at, or if you observe here, what is happening here, it is having the different layers here, convolutional layer, and there is a local search norm is there, and there is a max pooling, and then what is happening here, the output is being actually distributed into the different convolutional networks. Now why it is happening so? Because in Google Net, what happens, whatever the output is coming here, it is given to the different convolutional layers, and convolutional layers are having the different convolution filter size. Here it is the size of 1 cross 1, 3 cross 3, 5 cross 5, and 3 cross 3. And from this, whatever the output is coming, then this output is being merged. It is called as inception. This is called as inception module. So Google Net has this inception modules at the different levels here. You can see this is the inception, this is the inception module, inception module, inception modules. So it is actually works on the inception concept, that you will be doing the convolution with a different filter size and then combining the output from the those different convolution levels. Okay, that is what is called as inception levels. So in the Google Net, there are total 9 inception modules are there basically, and these inception modules are then stacked together. Okay, that is what exactly is the Google Net is all about. Okay, even in the Google Net, what happens, if you just look at here, 1 2 3, after 3 inception layers you can check your output. After this 3 inceptions layer you can check your output. After this total 9 inceptions layer you can check your output. Means there is a check of output after 3 inceptions layers also, after 6 inception layers also, and after finally 9 layers also. Okay, that is the beauty of the Google Net. So why this facility of the check of the output is there? Because if the output is becoming remain stagnated, or I will say it is stabilized after the 6 inception layer, if it is not having any change after up to 9 inception layer, then you need not to process your data onto your 9 inception level. You can simply process your data up to the 6 inception levels. So you can decide, okay, based on that, you can decide that how many inception layers that you want to, or inception models you want to put up into your Google Net. Okay, so that is what exactly we have done. So those were our 3 networks, and then we have done this ensembling here. The main objective of Ensemble is to minimize the generalization error basically. Okay, of one or more base learners. As I have 3 base learners here today, so I have used this Ensemble learning so that whatever the generalization error, or I will say whatever the cost function values are coming, and whatever the cost function errors are coming in all the 3 compact networks should be minimized. Okay, so for that we have used this simple Ensemble algorithm, where we are taking the training input data, then we are having the learning of the base learner models. Then what is happening, then we are taking this training pain data parameter, that is capital D, which is based on from one model then another model. This I is nothing but from I is moving from 1 to M, so M is nothing but the 3 models that we are having. Okay, so that is what exactly has been done here. Then we are taking this model Ensemble and getting its average. Okay, now we also augmented the data. When you have small data size, or when you are having the small data, what happens that you should increase your data. As I told you that you should feed large data to the deep learning networks. For that, you can, it's not necessary that if you're not being provided with the large data, then you can increase that data on your own by using the data augmentation methods. So we also have used the data augmentation methods of flips and rotation here, that we have flipped the data by angles. 50% of the images have been flipped, okay, in a horizontal direction, and the horizontal flipping is a mirror image basically. We also have given the rotation of 10 to -10 to +10 degrees, and that is how we have rotated our data. Okay, and that way we have increased the size of our data. This is the experimental setup that we have used, what machine we have used, how many epochs we have taken, okay, what batch size we have used, what loss function we have used, okay, all that details has been given here, that cross entropy, and we also have used the tenfold cross validation technique basically to validate our training of the network. Okay, so we have received this three performance parameters has been measured here by us, that is precision recall, and the F1 measure. For that we have taken all the output from the individual learner also. So if I using only only VGG, what precision I'm getting? 88.52 or 88.8008 is the recall, 88.19 is my F1 measure. If I take only mobile net, these are my results. If I take only Inception or only Google Net, then I'm getting these results. But if I'm using ensemble of this, you will see that the performance is better than all the individual base learner performance. Okay, so that is the advantage of the ensembling. Ensembling is not only reducing the generalization error, but it is also improving the performance of your task. Okay, intended task. That is what is the advantage of the ensembling, as I told you, right? We also have checked the class wise performance of the network, of our ensemble network. What classes we have taken? We have taken no pain class, mild pain, moderate pain, severe pain, and very severe pain. In all these 4 classes, the performance is coming high. For the no pain also, it is 96.83, 91.42 for the mild pain. Moderate for it, the precision is coming 90.86. For severe pain, the precision is coming 89.57. For the very severe, it is precision is coming 91.18. Now if you just look at these 2 figures here, no pain and the mild pain, these are the classes which are having a very small difference, but still our network is able to recognize though that no pain and the mild pain cases very accurately, and you can see the value of that precision is very high, 96%, 91%. That is the advantage of our method. Okay, so this is a confusion matrix that we have prepared and for our ensemble based model, and these results are already given into the earlier tables as well. Okay, now we also have compared our these results with the some of the results from the literature, that this is a Lucy et al., then Rodrigues, then Bellontia, then Hamel, then Barkshreddy. They have done some similar research in the recent past. But if you just look at their work, they have used only 2 pain levels, 3 pain levels, 4 pain levels. We have used maximum pain levels 5. Okay, which are these 5 pain levels. Why we have used 5 pain levels? These are the pain levels which are used for the subjective methods. As I told you that when the patient is self-reporting the pain, he will be reporting that in a 5 levels. So why not to have that to all the levels? So that is why we have taken all the 5 levels. We have used the data set. Okay, we have taken 16,000 samples. Okay, this or the classifiers use here SVM, then this is VGG16. Somebody has used CNN RNN. This is again SVM study. This is VGG and LSTM network, and this is our compact network. Now, if you just look at the performance parameters, our performance is coming very high compared to all the earlier studies from the literature. Okay, they have used the same data set of Ewan McMaster shoulder pain data set, and in the same data set they have used different classifiers, or I will say different machine learning approaches, but our machine learning approach is giving the best results compared to the earlier results reported in the literature. We also have done saliency map analysis, where actually by using the saliency maps, the discrimination can be understood in the cases of the pain, no pain, mild pain, moderate pain, severe pain, and the very severe pain. Okay, so these are the conclusions of my today's presentation, that yes, for correct diagnosis and the reliable treatment of the patient, this pain assessment is very important. It can play a very crucial role into that. 5 levels of pains we have understood, or we have learned, or we have studied into over this experiment. Okay, this whatever the pain assessment system that we have proposed here, it is actually learning more generalized features, okay, compared to other networks that is proposed into the literature. Because see, a single network can only have a specific feature representation, but if you are using ensemble sort of network, it will be having a generalized ensemble of different CNNs, resulting what we have understood, that ensembling is also reducing the generalization error. It is also improvising the performance, and whatever the results are provided by our this network, they are very competitive. And moreover, the pain related behavioral parameters such as body movements, these all can also be incorporated into the measurement of the pain. So for the information of the audience, I would like to inform them that yes, we have completed the pain assessment by using, not only by using the facial expression, we have also used the pain sounds, we also have used the body movements, and we have clubbed them. We have done the ensemble of these parameters and found a very innovative method or successful pain assessment method into our this project basically. Okay, so that is all from my side. Thank you so much for patiently hearing to me. Over to Dr. Yadav. If you have any question from the audience, you can put up into the chat box maybe, and we can resolve their queries.
Thank you so much, sir. Now I'll request audience to ask the queries. Anybody who's having query may please put up the query in the chat box.
See, this is a application is very important to is very important in machine learning or deep learning studies, because and what application we have picked up is very crucial for the medical fraternity. Okay, sooner or later somebody there will be, you will be able to see a separate system into the medical hospitals, where the patient will be asked to go into that room and get his pain report, and based on that pain report, the treatment of the patient will be done. And even there will be, you will be able to see a continuous pain monitoring system, just like what you see for the cardiac and the brain dynamics. Okay, so that is what is expected in near future in this pain domain. Till this point, very few studies are there, and I'm really happy to share that yes, our group has done a very significant contribution into this area. So I'm really glad. If you have any queries, you can ask me.
Yes, audience, any queries? So as of now, there is no query from the audience, but I'm having certain questions to ask, sir.
Okay, Arvindji, please.
So I think one of your works suggests a use of UNet for the medical image segmentation.
Yes.
Right. Now, how effective UNet is there in the segmentation of CT images?
CT images.
CT, yeah.
Yes. See, Arvindji, I want to tell you about the UNet. UNet is basically a structure which actually is able to generate the exact replica of your input data. Okay.
Right.
If you know the in UNet, it is having one compression stage, then there is a decompression stage. Okay. When it is actually decompressed, it actually regenerate that data. Okay. Right. The UNet will be more successful on CT images, or I will say on the images which are having less number of gray levels. Okay. Say that if you are applying it on the color images, you will be having the color shades, or the change of colors will be very high. Okay. Say that you are having RGB image, so you will be having R also, you will be having G also, and you will be having B also. And in that R and G and B also, the change of levels will be very high. Okay. While in case of say RGB images, grayscale images, you will be having say 256 gray levels only. Okay. So in that cases, unit success is very high.
Right.
So if you'll ask me that whether it will be very successful to apply the units on the medical images, I will surely say that yes, they will work more better than color images on the gray level images. Any gray level images.
Now there is a variant of this unit called residual unit.
Right.
And it is being used in combination of this unit. So we call it ensemble of these two.
Yes. Basically, what happened in this residual unit, there is a separate residual block is there. Okay. Whenever you process your data, when the data shifts from one level to another level in the unit, what happens? It actually takes the data from the previous layer, whatever the output is there, okay, and it directly reaches to the next level. While in case of residual unit, it only not takes the process data, it also takes the raw data. Okay. Say that one data is entering to the level, level of the unit, okay, that is your raw data, it is entering to your level 1, and after that level 1 you will be having the process data, okay. But if you are using the residual will use that process data as well as your raw data along with that, and then it will take it to the next stage. While in the conventional unit, what happens? Only the data processed from the previous level will go to the next level. Okay.
Right.
Now, what is the advantage of doing this? Let me tell you. Convolutional layers actually generate the features. Okay.
Right.
In those features, there are possibility that there will be a redundant features, though there will be features, those will not be usable. Okay. And you may also find that whatever the features are available in the raw data or the earlier level may be useful. Okay. After the processing, that useful information may be getting lost. So that loss of information can be neglected by doing the residual mechanism. Okay. Right. Say that some good features are being if there are some good features being lost during the process, and their retention is important to us, so you can retain that by using the residual block. That is an advantage.
So ensemble of this unit and residual unit is going to give you more significant features which will be able to capture the tumor information.
Yes, useful information in the residual unit case will be more compared to conventional unit. That is, I can assuredly tell you.
Right. So though it is going to improve the complexity, but at the same time it is going to give you a perfect information that will be more precise in order to predict something.
Yes. Now the complexity that you are talking about, or say that trainable parameters or the network is going to become complex. So that burden will come on your machine. If you are having a very good machines today, because if you'll say that if you are having a computer machine having 64 GB graphical unit GPU, okay, 64 GB GPU, so it can process that data very easily. So that complexity can be handled by your GPU. If you are having a very good GPUs with you, do not worry much about the complexity of the network. Focus on the performance of the network. Right, that is what I suggest.
Because earlier the issue was complexity, but nowadays we are having high specification systems available with us. So one should not be worried about the complexity and all these things. Rather, the focus should be on accuracy and preciseness.
Yes. And in fact, I suggest, or what I experienced today, with my experience, I can tell you, in deep learning, this complexity, if you are having if you can build this complexity on your own with the precision, then I can assure you that you can have a better systems. You can have a very fruitful systems. Do not worry about this complexity if you are having a very good systems with you.
Right. Thank you so much, sir, for enlightening us with the thought process. And in fact, the area that you have suggested today is something that I have never heard before. So yes, sir. Probably this is something the listeners might have found it very useful. That lots of work is going on in healthcare industry. Probably we are not aware of that, but these small things are making all the differences. So as you said that okay, tomorrow you might be having some machine where you can get the information about your pain parameters, very much similar to what ACG and other modalities are doing. So once again, sir, on behalf of Harvard University PhD section, I'm very thankful to you for enlightening all of us with the knowledge that you have shared today. Thank you so much, sir. And I
Thank you.
hope in future also we'll be getting the benefit of your knowledge.
Surely, Dr. Yadav. Thank you so much for inviting me today. Okay, I hope that some of your researchers will get inspired from the studies, and they will come up with similar ideas and improvise the research at University. Thank you so much. Thank you once again.
That was the idea behind organizing such PhD webinars,
Yes.
which is only for the faculty members and researchers. Because most of the time we organize it for the students of BTech or MTech, but not necessarily everybody would be interested in this kind of research activity.
Rightly said, sir.
Okay, sir. Thank you so much.
Okay,
Have
sir.
a great
Thank you.
day. Take care.
Thank you.
Participants, thank you so much for being with us. And I hope this information is definitely going to be useful to you. Thank you.